Everyone, for today's lesson, we are going to learn about how to apply polynomial equations in context. The primary problems that we're going to be working with in this lesson is going to be volume problems pertaining to the volume, more specifically of prisms. So before we get started, the first thing I would like to do is remind ourselves of what the volume of a prism is. And this is something that we learned when we were in geometry class. And the volume of a prism is length times width times height. And if you think about it, we have three different measurements or three different pieces being multiplied together. And that means that our result is going to be something with units that will be cubed, which is raised to a higher degree. And a lot of the problems that we've been working with in this unit have been cubic functions. So let's go ahead and get started with example number one. In example number one, it says, you are building a wooden square sandbox. This is a wooden square sandbox for a local playground. You want the volume of the box to be 16 cubic feet. And you want the height of the box to be x feet. And the length of each side of the square base to be x plus 3 feet. What are the dimensions? So the first thing I would do is draw a picture just to get a sense of what we're doing here. So I'm going to draw a square, and this is going to be a prism. So that means that I need to make sure that I have some kind of height going on here. So this is my sandbox, if you can imagine sand being in here. And this is a square, so that means this is a right angle, and all the way around, we'll see that all of our side lengths are the same. We want each length to be an x plus 3 and an x plus 3, and we want our height to be x. We know that the volume that we are looking for is 16 cubic feet. And so we're going to be setting up an equation where I'm going to let my volume be 16, and it's going to be equal to my length, which is x plus 3, times my width, which is x plus 3, times my height, which is x. Now, truth be told, you don't have to order it like this. If it makes you feel better to put x in front, go for it. There's nothing wrong with that. But because this is a polynomial equation, we need this equation to equal 0. So what I'm going to do is I'm going to FOIL out the parentheses and then bring 16 to the other side to make this equation equal to 0. So I'm going to write 16 equals x squared plus 3x plus 3x plus 9, and I'm going to multiply all of that still by x. If you recognize that whenever you multiply two binomials together that are the same, it will produce a PST, then go ahead and use that pattern. If you are not comfortable with patterns yet at this moment, that's not a big deal. Eventually, you will get there. So I'm going to write 16 is equal to x squared plus 6x plus 9 times x still on the outside. And then I'm going to do a couple of steps in the same line. What I'm going to do is I'm going to subtract 16 on both sides so that this equation is equal to 0. And then I'm going to distribute x to all of the terms to make this x cubed plus 6x squared plus 9x, and then finally minus 16. Now this equation is equal to 0. So whenever we have these types of problems equal to 0, we always try to see if we can factor by grouping. So I'm going to put parentheses around the first two terms and the last two terms. And I can see that these two terms have in common a GCF of x squared. So I'm going to write an x plus 6 inside. Plus 9 and 16, they both have in common no, they have nothing in common. Oh my. So that means that this problem is not factorable by grouping. Don't worry about that. We have a strategy. Whenever polynomial equations are not factorable by grouping, we can use our rational zero theorem to identify possible rational zeros and then use synthetic division so that we can find something that works. So my possible rational zeros are the factors of 16 divided by the factors of 1. And anything divided by 1, it's just itself. So I have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. So using a little bit of logic, we're going to start with number 1. So I'm going to test positive 1 to see if it will work. And I'm going to put in 1, 6, 9, and negative 16. And remember that it works if we end up with a remainder of 0. So I'm going to bring down the number 1. 1 times 1 is 1. 6 plus 1 is 7. 1 times 7 is 7. 9 plus 7 is 16. 1 times 16 is 16. And negative 16 plus 16 is 0. Cool. We got very lucky. So what does this one mean? It means that my factorization of my polynomial will include x minus 1. Remember that it's the opposite of what we see. And what's remaining is a 1, 7, and 16, and that's going to represent the coefficients of my quadratic. And it's quadratic because it's 1 degree less than our polynomial that we have. So I'm going to write 0 equals x minus 1 times x squared plus 7x plus 16. And I'm going to see if I can factor 16 or this polynomial even more, this quadratic even more. Looking at the factors of 16, I have 1 and 16, 2 and 8, and 4 and 4. And my goal is to get a 7, but I'm looking at these numbers and I'm clearly seeing that none of them add to equal 7. They equal 17, 10, and 8, but not 7. So this tells me that it's not factorable, but I have the quadratic formula. So far my zeros are x equals 1, and then now I'm going to use the quadratic formula, which is x equals the opposite of b, which is negative 7, plus or minus the square root of b squared, so that's 7 squared, minus 4 times 1 times 16. This is all over 2 times 1. So I end up with x is equal to negative 7 plus or minus the square root. And if we put this into our calculator, we end up with negative 15 over 2, which is imaginary. And that doesn't make any sense for this particular problem with context. So therefore, the answer is no, that does not work at all. And our only solution is x equals 1. So going back to our picture, if x equals 1, that means our dimensions are 1 feet by 3 plus 1 is 4 feet. And finally, 1 plus 3, which is 4 feet. So our dimensions are 1 foot by 4 feet by 4 feet. And that's our length, our width, and our height. All right, let's go ahead and move on to our second example. In our second example, what was nice about this problem is that all we have to do for this problem is we just need to identify x. And so we're going to basically do the same exact type of problem all over again. This time around, we're told that the volume is equal to 40 inches cubed. And I am told that one of our dimensions is x minus 4. This one is 2x, and this one is x minus 1. So I'm going to multiply all of these dimensions together and set it equal to 40. And they can be multiplied in any order that you see. So I'm going to write this as 40 is equal to 2x times x minus 1 times x minus 4. And I'm going to multiply 2x to my first parenthesis, make it 40 equals 2x squared minus 2x, and I'm going to FOIL that with x minus 4. So now I have 40 is equal to 2x cubed minus 8x squared minus 2x squared plus 8x. And now I'm going to combine my like terms and bring 40 to the other side. So because this is a polynomial equation, it has to equal 0. So I'm going to write 2x cubed negative 8x squared minus 2x squared, that is minus 10x squared, plus 8x minus 40. And I'm going to see if I can factor by grouping. So I'm going to put parentheses around the first two terms and parentheses around the last two terms. 2x cubed and 10x squared, they both have in common a 2x squared, with the leftovers being x minus 5. Plus 8 and 40 both have in common an 8, with our leftovers also being x minus 5. So that means this is indeed factorable, which is really nice. So my next line is going to be the fact that these two terms both have in common an x minus 5. So I'll make that my first parenthesis of x minus 5 And then we have 2x squared plus 8, which is our outsiders. But what I notice is that 2x and 8 have something in common. They have in common the number 2. So I'm going to go back to my original equation, and I notice that 2, 10, 8, and 40 also all have in common a 2. So I'm going to factor completely by factoring out a 2, and I'm going to put it in front and make this x minus 5 times x squared plus 4. So now this is factored completely, and I'm going to set each parenthesis equal to 0. So I end up with x equals 5, and then I'm going to write x squared plus 4 equal to 0. I'm going to subtract 4 on both sides, and then I'm going to take the square root of both sides, and I end up with x is equal to plus or minus 2i, which is once again imaginary. And if it's imaginary, that means that it's not a number that we can actually use in context. So therefore, our answer is only x equals 5. Now, if you wanted to identify the dimensions, you totally could do that. This is going to be 5 minus 4, which is going to equal 1 inch, because this is inches this time. We have 2 times 5, which is equal to 10 inches. And then 5 minus 1, which is going to equal 4 inches. So our dimensions are going to be 1 inch by 10 inches by 4 inches. All right, let's go ahead and move on to the next page. In this problem, it is a solo question, and I will let you guys do this one on your own. And the next question right here is a pair question, but I'm going to make sure that I show it to you guys this time. Normally I skip the pair questions and we talk about it the next time I see you, but I really want to make sure that we are aware of what to do for this pair question. So in this problem, it says that the volume of a box is given by 2x cubed minus 11x squared plus 10x plus 8. And what we want to do is we want to find an expression for the missing dimension. So what I have here is 2x plus 1 and an x minus 4, and I just don't know what that last dimension is. So what I do know is that this volume expression, if I were to factor it, I would break it apart into 3 parentheses. And one of those parentheses is going to be a 2x plus 1, and the other parenthesis is going to be an x minus 4. I just don't know what the third one is going to be. So fortunately for us, there are 2 approaches for this problem. The first one is synthetic division. And what you do for synthetic division is just like we've always done, whenever we have a factor, we identify the 0 that's produced from that factor. So like the 0 that would be produced from 2x plus 1, that would be x equals negative 1/2. And the 0 that's produced from x minus 4 is x equals 4. So what I'm going to do is I'm going to put 4 inside of the little box because that's an easier number for me to work with. And I'm going to work with all of the coefficients from the expression for volume. And I'm going to write 2, negative 11, 10, and 8. And I'm going to bring down the 2. 4 times 2 is 8. Negative 11 plus 8 is negative 3. 4 times negative 3 is negative 12. 10 minus 12 is negative 2. 4 times negative 2 is 8. 8 minus 8 is 0, which is awesome. That's exactly what we expected. So in our factorization, this 4 comes from x minus 4, and now I'm left with 2x squared minus 3x minus 2. What's really cool is that I already know one of the factors of 2x squared minus 3x minus 2, and that comes from up here. That's going to be a 2x plus 1 is one of the factors. Remember that I'm just trying to find what that third one is. So what's cool is that because I already know what half of it is, I can kind of do like a process of elimination when it comes to factoring. So I know that if I were to split apart that 2x squared, I would have split it apart into a 2x and an x. And I would have to look at the factors of negative 2 and the factors of 2 and somehow get a negative 3. And I already have a positive 1 right here. And I know that positive 1 times negative 2 is equal to negative 2. I just need to check and verify the O and the I of FOIL. So I'm going to go 2 times negative 2, which is negative 4, and 1 times 1 is equal to 1, and -4 plus 1 is -3. So this is the factorization, and the missing term ends up being x minus 2. So that is our missing dimension. Now, if we knew that this was in inches or feet or whatever our units were, we would write our answer as x minus 2 inches or whatever units is talked about in this particular problem. And that is how you solve it using synthetic division. Next time I see you in class, I would like to talk to you guys about how to solve this using long division. So if you want to try to attempt this using long division, think about what that's going to look like, and then we will go from there. My hint to you is that you're going to be using both pairs of parentheses. That is the end of this lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.